Hello class, this is the video for section 6.5, assessing normality. Now, in this section, we'll be looking at the visual inspection of the histogram to see if it is roughly bell-shaped, identify any outliers, and constructing a normal quantile plot. And so to assess for the histogram, normality, you want to know that the histogram is a bell shape, and then if it has an outlier and so on, okay? So that is the goal. Now, note, we will use the StatScram to construct the QQ plot, which is the same as the normal quantile plot. We will skip the construction of that manually, okay? So the normal quantile plot, which is also the same as the QQ plot, as we did in the previous chapter, that not just the chapter 5, but before that, chapter 2, we did look at some things about normality, if you remember. Now, the normal quantile plot, which is also the normal probability plot. So it's a graph that the x-axis is your x variable, and then the y-axis is what your z-scores, all right, your z-scores. So the vertical axis is your z-scores, and then your horizontal axis is your x values, depends on your data or the original value, okay. Now, for histogram, procedure for determining whether it is reasonable to assume that sample data are from a population having a normal distribution. Your histogram, if you construct it, it departs dramatically from a bell shape. We conclude that the data do not have a normal distribution. In other words, if your histogram is a bell shape or roughly bell shape, we conclude it is from normal distribution. Okay, and outliers, we can identify outliers if there is more than one outlier present from the histogram. You conclude that the data might not have a normal distribution, okay, more than one. So if you have 0 or 1, then possibly we can conclude that it is from normal distribution. And that is the third point, that a normal quantile plot, if the histogram is basically, symmetric, and the number of outliers is 0 or 1, we use technology to generate the normal quantile plot. In other words, from a histogram, which is a symmetric, which we know is normal, and it has some outliers like 0 or 1, we use the quantile plot to affirm our inspection or our belief, okay, or our conclusion, right? So the procedure continues that apply the following criteria to determine whether the distribution is what is normal. These criteria can be used loosely for small samples, but they should be used more strictly for large samples, okay? Now remember, in this class, a small sample is less or equal to 30, and if it is greater than 30, then that is what considered as large. So for a normal distribution, if the pattern of the points, please note, is reasonably close to a straight line, and the points do not show any systematic pattern, that is not a straight line pattern, okay? So in other words, if you want to show that the QQ plot is a normal, what the requirement is that, one, the points, all right, that is your X and Y points, the Y-axis, the Y values is your the Z-scores, and then the X is your data, okay? And if it's straight, reasonably straight to close to a straight line, and the points, okay, show a systematic pattern that is a straight line, then we say that it is what? It is normally distributed, or your X is normally distributed, okay? So it's very important. On the other hand, if it's not normally distributed, there are two things, either or both of them at the same time. Okay, if either or both of these two conditions apply, that the points do not lie reasonably close to a straight line. So you can use that alone to say that it is not normally distributed, or you can use this alone that the points show some systematic pattern that is not a straight line pattern. Or you can have a graph that has both of them. So either the first or the second to conclude that it is not normal, or both of them to conclude that it's not normal. Okay. Now, so let's look at this, this graph. If you look at the histogram to the left, okay, you'll see that it's a roughly what normal. Okay, it is roughly normal. And the points here don't seem to be outliers. Okay, the 140 and beyond that doesn't seem to be the one of each. Doesn't seem to be an outlier. Now let's look at the QQ plot. All right, that's the y-axis is the z-scores, which is for a normal distribution between what 3 standard deviation. That's why I have 0 from to the top is what 1 to 3, and then -1 to what -3. Okay. Now if you look at it, this pattern, all right, this is the points are reasonably close to a straight line. Okay, except these last two, but most of them close to what a straight line. Okay, and it doesn't show any pattern along the line. Okay, so we say that this is normal. Okay, so we say that a quantile plot shows points that are reasonably close to a straight line, and the points do not show any other systematic pattern that is not a straight line. Okay, it is safe to assume that these IQ scores, all right, this is from IQ score, are from what population that has a normal distribution. Okay. Now let's look at a second example. This is a uniform distribution. And then the histogram to the left, and then the QQ plot or the normal quantile plot is to the right. Now I could see the points are close to what a straight line. However, there is a systematic pattern, like a snake, okay, going up the pole or coming down. So along the line, it's like a snake. That's a systematic pattern. So because of that, we say that this is not from what a normal distribution. Now, without even looking at the what they call the histogram, just the QQ plot, it is close to a straight line, all right? However, reasonably, but it shows a systematic pattern along the line. Okay, so we say that we conclude that these sample values are from a population having a distribution that is not normal. Okay, or it's not from a normal distribution. Now, look at this. This is a Monday rainfall in inches, and then the frequency. As we can see, this has some outliers, all right? It has at least one outlier here, okay? And of course, it is not a bell shape, the histogram. It is not, it is right skewed. So of course, it won't come from a normal distribution. But look at the QQ plot. Definitely, it is not. The points do not at all close to the straight line. They don't lie along the line at all. And you don't even have to look at it, whether it is showing some systematic pattern at all. So in this case, accurately, this is not normal. Okay, so I have two graphs here. Okay, you have a male systolic blood pressure, and the airline arriving delay times. All right, now let's look at the first one on the left. Okay, the normal quantile plot. Okay, this is reasonably close to a straight line. Okay, reasonably close to a straight line. So the one to the left is what normally distributed. Okay, but look at the one to the right. The one to the right definitely it is not close to a straight line and doesn't show any systematic pattern along the line at all. So the one to the right is not from normal distribution. The one to the left is from what? Normal distribution. Okay. Now in statistics, sometimes when you have this one, there are certain ways that we can do some transformation. So tools for determining what normality. Okay, in this class that we have learned, we can use a histogram. Okay, so again, if the requirement of the normal distribution is not too strict, simply look at the histogram and find the number of outliers. If you have just 1, 0, or 1, then treat the population as what? From a normal distribution. Okay, so in other words, the sample size is small, all right? And you want to look at that and check for outliers. If you have more than 1, then it's not normal. Okay. Then you can use the QQ plot. That's what the Stats Crunch is called. The normal quantile plot is a QQ plot, as I've mentioned in the past. Okay. So the plots can be difficult to construct on your own, that's by hand, but they can be generated with what? If you have a TI-83 or 84 plus calculator or a suitable software, like in this case, StatCrunch or Excel, Minitab, or what? The StatDisk. These are all softwares that you can use to construct the QQ plot. Now, there are advanced methods that we can also use. In addition to the procedure discussed in this session, there are others more advanced procedures for assessing normality, such as the chi-square goodness of fit test, which is beyond, we don't do this in this class. In fact, in chapter 11, the only chapter that we don't cover at all in this class covers the chi-square goodness of fit test, the Kolmogorov-Smirnov test. Okay, that is for non-parametric statistics, and the others as mentioned here. Okay, but we don't cover this. Okay. Many data sets have a distribution that is not normal, but when we do some transformation, all right, do some transformation so that the modified values have what? A normal distribution. So any transformation, whether you are adding 1 to each or subtracting a certain quantity, you are squaring it or something, any form of transformation will be what? Normal distributed. Okay, one common transformation is just add what? 1 to it. Okay, each value of x by taking its logarithm, that is 1, or you can use what? Natural logarithms or log to the base 10, doesn't matter. If any original values are 0, take logarithm of values of what? X plus 1. All right, so take logarithms of that, and that should be normal. Okay, if the distribution of the logarithms of the values is a normal distribution, then the distribution of the original value is called a log normal distribution. However, we can't take logarithms of normally distributed random samples because of negative values. Okay, so the samples are not normal, but the exponential of what normal is log normal, which is a right skewed. Okay, so I wanted to make that note. Now we will just do homework problems number 1 and 3. In fact, there are 4 problems. There's 4 questions on the homework 6.5. I will do 2 of them with you. Okay, so let us do that right now. All right, so we go to 6.5. Let me preview that. You see if you, okay, it is sharing that. Let me, yeah. going to make this bigger. Okay, so question 1, we are given a QQ plot here, and we are asked to, actually, did I say 4 questions? There are, 5 questions in there on it. So I'm doing 2. Look at the QQ plot here. I can make it bigger. All right, as you can see. Now, this is definitely not along the what? It's not, the points don't lie reasonably along the close to a straight line at all. All right, so this is not a normal distribution. So he said, does the normal contour plots depict a sample data from a population with a normal distribution? No, the points do not lie close to a straight line. The points exhibit some systematic pattern that is not a straight line. Okay, they don't lie to that. So basically, that would be our answer. Okay, so we have that. Then let's go to question number 3. Now, question number 3, it reads, okay, it says use a calculator, all right? Use a calculator or a computer software to generate a normal contour plot for the data in the accompanying what table. Then determine whether the table comes from a normally distributed population. All right, so we open this and open this in the StatCrunch. Okay, I hope you see my, let me make this, perhaps let me make this bigger. All right, so making that you are seeing that, okay. Right, so we're going to make a QQ plot of that. To go to graph and scroll down and do a QQ plot. Select your variable, and you want to check this box because the z-scores are on the y-axis. So you want to make sure you check that and then compute. Okay, so here is our, this is our QQ plot from the data. Now, as you can see, they lie quite to a straight line, all right? But there is a systematic pattern along it, just like a snake. So we say that this is not a normal distribution. So they don't like to as close to that. And then the best reason, the most significant one is that there is systematic pattern that is not a straight line. Okay, so let's go to do that. So let's go back to the question. Okay, let me minimize that and make this is the question. So let's close that. So based on this, which was the answer? The answer for that is what is a C. So let's say final check. Let's check that is good. And then what's the reason? Okay, A, the distribution is not normal. The points are reasonably close to a straight line. That's not true. Okay, the distribution is normal. It's not normal because there's a systematic pattern. That's not. The distribution is not normal. The points show a systematic pattern that is not a straight line. And then the distribution is normal. So the correct answer is what? Is C. And that is it. Okay, so we've done the 2 examples there. I hope this is helpful, and thank you.